I'm Ravi Handa. Welcome to the session on divisibility and factors. Well, this is my Twitter handle in case you have doubts or you just want to abuse me for the fonts that I have used. What we'll discuss in today's session is that if I'm given a number, how do I find out its number of factors? Not only that, how do I find out how many even factors it has or the odd factors it has? We will also discuss how to find out the sum of all those factors, and also let's say I just want to add the even factors. How do I do that? Or if I want to add just the odd factors, how do I do that? In the next 7 to 8 minutes, you will know all this, hopefully. Well, let's say I'm given a number n, which is of the format of a to the power p into b to the power q into c to the power r. A, B, C are my prime numbers, whereas P, Q, R are their powers. Then its number of factors will be given by P plus 1 into Q plus 1 into R plus 1. Yes, the formula is as simple as that. But it is even more important to understand why is this formula valid? Why is it P plus 1 into Q plus 1 into R plus 1 and not any other value? For that, let us take an example. Suppose I am given a number n which is 2 to the power 5 into 3 to the power 4 into 5 to the power 2, and I am supposed to find out its factors. So essentially what I have is I have these 5 2's, 2 2 2 2 2, 5 2's, and I have 4 3's and I have 2 5's. Now to form a factor of this n, what do I need to do? I can take any number of 2's from this particular set of 5 2's. Let's say I decided to take 2 2's from it. Not only that, I can take any number of 3's from this set. Say I decided to take 1 3 from it. I can decide to take any number of 5's from it. I decide to take 0 5's from it. Then what do I get? I get 2 into 2 into 3, which is actually equal to 12, and that 12 is a factor of n. Very obvious. How does that lead to the number of factors? Just think of the process that we did here. We chose any number of 2's from this 5, any number of 3's from this set of 3's, and any number of 5's from this set of 5's. Apply, and every selection, each selection of a particular subset from this will give me a factor. As you have seen here, 2 into 2 into 3 gave me 12, which is a factor of n. So for number of factors, what I need to decide is how many 2's can I take? I can take 1, I can take 2 2's, I can take maybe let's say 3 2's, I can take all 5 2's, or I can decide not to take a 2 at all. So the number of choices that this set of 2 offers me is actually 6. Very similarly, the number of choices that this set of 3 offers me is 5. I can decide to take 1, I can decide to take 2 of them, I can decide to take 3 of them, I can decide to take all 4 of them, or I can decide not to take any 3. Similarly, for the 5 part as well, I have 3 choices. For 5, I can take 1 of them, 2 of them, or none of them. So the total number of choices that I can make, that will give me the number of factors, which in this case comes out as 6 into 5 into 3 or 90. Similar idea is applied here. A to the power p. So how many a's can I take? I can take 1a, I can take 2 a's, I can take 3 a's, up to pa's. Or I can decide not to take an a at all, which gives me p plus 1 choices. Very similarly, I can decide to take 1b or 2b or 3b's or 4b's up to qb's. And so the total number of choices, those q and not taking a b at all for the 1, total number of choices is q plus 1. And hence that is how rather we get this formula of p plus 1 into q plus 1 into r plus 1. Which leads me to the next thing. Suppose now the question is what is the number of, out of these 90 factors that I have got for n, how many are even? Well, for doing that, all I need to do is assume that I have taken a 2. 1, 2 is a compulsion. So if 1, 2 is a compulsion, my new set is, this is removed. And if this is removed, I'm left with 4 2s, 4 3s and 2 5s. So what is the number of choices now? 5 for the 2s, 5 for the 3s and 3 for the 5s, which gives me a total of 75. 5 into 5, 25 into 3 is 75. So my number n has 75 even factors. For the odd number of factors, well, what I need to consider is that I cannot take any 2 at all. And if I cannot take any 2 at all, I'm just left with the set of 4 3s and 2 5s. So the total number of choices has now become as, forgetting the 2s, from this set of 4 3s, total number of choices is 5. From this set of 2 5s, total number of choices is 3. I can take 1, I can take 2, I can take none. So the total of number of odd factors is 5 into 3, 15. Well, you could have also done it as, let's say you found out the even number of even factors as 75. You have found out the total as 90. Number of odd factors is going to be the difference of the two values. Let me just get the number of 2s again, which were here. So here I had 5 2s. This set of a particular type of question which can also be asked is, what is the number of factors which are divisible by 12? For that, for this type of question, all you need to do is divide my number n by 12. So what I'll do is, I'll remove the 2 2s and a 3 which is required to make a 12. Now what am I left with? I'm left with 3 2s, 3 3s and 2 5s. So the number of factors which is divisible by 12 is 4 because of these 3 2s, number of choices, 4 because of these 3 3s and 3 because of the 2 5s which are remaining. So number of factors of n, the original number which was given to me, which are indeed divisible by 12, is nothing else but 4 into 4 into 3, which is actually 16 into 3 or 48. Let me just write the original number again, which is 5 2s, 4 3s and 2 5s. Now, looking at the next set of questions, which is finding out the sum of all these factors. I figured out that there are 90 factors. Now, how do I get the sum of all of them? Well, it's very simple. All you need to do is 2 to the power 0. All you need to do is 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 plus 2 cube plus 2 to the power 4 plus 2 to the power 5. This will be multiplied with 3 to the power 0 plus 3 to the power 1 plus 3 square plus 3 cube plus 3 to the power 4. And finally, this will be multiplied with 5 to the power of 0 plus 5 to the power of 1 plus 5 square. Now, do you realize why have I done this? Because I had 5 2s, 4 3s and 2 5s. So this gives me the upper limit. But why this formula? The point to note is that there are 6 terms here, there are 5 terms here and there are 3 terms here. You take any multiple of this, it will lead to one unique factor. What I am trying to say is, let's say you take 2 square from here, this 2 square, you take 3 to the power 1 from here and 5 to the power 0 from the third set. What do you get? You get 12, which is a factor. Suppose you take 2 to the power 5 from here, 3 to the power 0 and 5 to the power 0. What do you get? You get 32, which is also a factor of n. Every product, every term in the expansion of this thing will be a factor. So sum of all of them will be the sum of all the factors. How many terms will be there? Well, there are 6 terms here, 5 terms here and 3 terms here. So total number of terms which would result in the expansion will be 6 for this into 5 for this into 3 for this part, which is 90, which if you notice is nothing else but the number of factors here. Now, what will be the sum of even factors? Well, apply the exact same idea as is used here. I'll just copy paste this. Yeah, but what is the difference? Now I need to have compulsorily at least one 2. So I cannot have a 2 to the power 0 in it. And the result which is left, that is 2 to the power 1 to 2 to the power 5, 3 to the power 0 to 3 to the power 4 and 5 to the power 0 plus 5 to the power 1 plus 5 square. Whatever is the result of this product, that will be the sum of all the even factors that my number n has. Very similarly, for sum of all the odd factors, I guess you would know it by now. What do I need to remove from this? I need to remove all the powers of 2 which exist. That is, I will remove all the powers of 2. What am I left with? I am left with just 2 to the power 0, which is effectively nothing else but 1. That being multiplied with all the others. So, continuing with this idea, the final sort of question, what will be sum of all the factors which are divisible by 12? This is sum of all the factors. Now, what do I remove from it? My number has to be divisible by at least 2 square. So, what do I do in that case? If it has to be divisible by at least 2 square, that is for 12, you saw that there were 4 terms that I needed to consider because I had removed 2 2's from here. Very similarly, I will remove 2 to the power 1 and 2 to the power 0 from here because I need at least 2 square for it to be divisible by 12. Very similarly, in the case of 3, I need for it to be divisible by 3 to the power 1. So I will remove this part, and what am I left with? 3 to the power 1 plus 3 square, 3 cube, 3 to the power 4. Has no significance on 5, and so sum of all the factors which are divisible by 12 is 2 square plus 2 cube plus 2 to the power 4 plus 2 to the power 5 multiplied with 3 to the power 1, 3 square, 3 cube and 3 to the power 4 multiplied with 5 to the power 0, 5 to the power 1 and 5 square. Hopefully this session has clarified your doubts or your concerns with how to find out the number of factors, that is p plus 1, q plus 1, r plus 1 once the number is given. For the number of even factors, all you need to do is consider that it will have at least 1 2. For the number of odd factors, you have to consider that it has absolutely no 2's at all and all you have is just 3's and 5's. Similarly, you can do it for divisible by 12 and stuff. For sum of all the factors, all you need to do is consider increasing powers of the prime factors till the highest power possible. 2 to the power 0 till 2 to the power 5, 3 to the power 0 till 3 to the power 4, 5 to the power 0 till 5 square. And with the help of this, you can solve all questions which are based on divisibility and factors. Hope you found this session helpful. If you still have any doubts, this is my Twitter handle @RaviHanda. Feel free to tweet me or just reach out to me for any feedback. Thank you.